Imagine a city unlike anything humanity has ever built before. A city with no roads, no traffic lights, no private cars, no endless traffic jams. Instead, imagine a perfectly connected city stretching across the Saudi Arabian desert for nearly 170 kilometers, where every school, hospital, office, shopping center, and park is only a 5-minute walk away. It sounds like science fiction, but Saudi Arabia is turning this incredible vision into reality. Welcome to the Line, one of the most ambitious engineering projects ever attempted in human history. This futuristic megacity is designed to completely change the way people live, travel, work, and interact with each other. Instead of expanding outward like every modern city, the line rises vertically inside two enormous mirrored skyscrapers that stretch farther than the eye can see. Some people call it the city of the future. Others believe it is an impossible dream that will never be completed. With an estimated investment worth hundreds of billions of dollars, thousands of engineers, architects, scientists, and construction workers are working day and night to transform empty desert into one of the greatest engineering achievements ever attempted. But the real question is, can this impossible city actually become reality? Or will it become the world's most expensive unfinished project? To answer that question, we first need to understand why Saudi Arabia decided to build something the world has never seen before. For decades, Saudi Arabia's economy has depended heavily on oil. Oil transformed the country into one of the wealthiest nations on earth. However, leaders understand that oil will not remain the world's primary energy source forever. As renewable energy, electric vehicles, and new technologies continue to grow, Saudi Arabia wants to prepare for the future by creating an economy that depends on innovation, tourism, technology, advanced manufacturing, artificial intelligence, and sustainable development instead of oil alone. That long-term strategy is known as Vision 2030. The line is one of its most important projects. Instead of simply building another modern city, Saudi Arabia wants to build a completely new model for urban life. Today's cities have many problems. Traffic wastes countless hours every day. Air pollution continues to increase. People travel long distances between their homes, workplaces, schools, hospitals, and shopping centers. Roads require enormous amounts of land. Cars consume huge amounts of energy. Urban expansion destroys natural habitats. Engineers working on the line believe there is a better solution. Instead of designing cities around cars, design the city around people. Inside the line, almost everything a person needs will be available within a 5-minute walk. Schools, hospitals, restaurants, shopping malls, sports facilities, parks, entertainment, offices. Everything is placed close together to reduce unnecessary travel. For longer journeys, an ultra-high-speed transportation system will move passengers from one end of the city to the other in only about 20 minutes, without traffic lights, without highways, without private vehicles. It is an idea unlike anything built before. The location itself is equally extraordinary. The line is being constructed in northwestern Saudi Arabia as part of NEOM, an enormous development covering thousands of square kilometers near the Red Sea. This region offers access to international shipping routes, renewable energy resources, tourism opportunities, and future technology industries. From above, the construction site looks almost unbelievable. Massive excavation equipment moves across the desert. Hundreds of cranes rise above the landscape. Thousands of construction vehicles transport steel, concrete, machinery, and materials every single day. Entire mountains are being reshaped to prepare the foundations for what could become one of the largest buildings ever created. Unlike ordinary skyscrapers that stand independently, the line consists of two parallel mirrored structures running side by side across the desert. Together, They will create a narrow urban corridor approximately 200 meters wide, but rising hundreds of meters into the sky. Millions of people could eventually live inside this single continuous city. From the outside, the mirrored walls will reflect the surrounding mountains and desert, allowing the massive structure to blend into the natural landscape. During sunrise and sunset, the reflections are expected to create one of the most breathtaking architectural sights ever seen. But making such a vision become reality presents engineering challenges unlike anything the construction industry has faced before. Building one skyscraper is already an extraordinary achievement. Building thousands of inside the city, transportation will be unlike anything seen in today's major cities. Since there are no traditional roads or private cars, people will rely on a high-speed underground transportation network. Advanced electric trains are expected to travel at extremely high speeds, allowing passengers to move from one end of the line to the other in around 20 minutes. Artificial intelligence will coordinate transportation schedules, reduce waiting times, and improve efficiency. Freight deliveries, emergency services, and maintenance systems will also operate through dedicated underground networks, keeping the city's surface quiet, clean, and free from heavy traffic. Above ground, residents will walk through green parks, shopping districts, residential neighborhoods, offices, schools, and entertainment areas connected by pedestrian-friendly pathways. Nature will be integrated into the city through gardens, green spaces, and climate-controlled environments designed to improve quality of life even in the harsh desert climate. Everything inside the line is being designed to make daily life simpler, faster, and healthier. But while the vision sounds extraordinary, turning these ambitious plans into reality requires solving engineering problems that have never been faced on this scale before. And as construction continues, the world watches closely to see whether this futuristic dream can truly become one of humanity's greatest engineering achievements. As the world's attention remains fixed on the line, another challenge begins to emerge. Building the city is only half the mission. The real challenge is making it function every single day. A city designed for millions of residents cannot rely on traditional infrastructure. Everything must be smarter, faster, and more efficient than any city ever built before. That is where artificial intelligence becomes one of the most important parts of the entire project. Unlike conventional cities where traffic lights, public transport, energy systems, and emergency services operate independently, the line aims to connect everything into one intelligent digital network. Thousands of sensors will constantly monitor the city's operations. These sensors will collect information about electricity consumption, water usage, air quality, transportation, weather conditions, structural movement, and even crowd density. Artificial intelligence will analyze this information in real time. If a train is delayed, the system instantly adjusts nearby schedules. If electricity demand suddenly increases, power is automatically redirected from battery storage or renewable energy sources. If a water pipe develops a leak, maintenance teams receive an alert before residents even notice a problem. The goal is simple: prevent problems before they happen. Healthcare inside the line could also be transformed by technology. Hospitals may use artificial intelligence to assist doctors in diagnosing diseases more quickly. Remote medical monitoring could allow patients to receive treatment without leaving their homes. Autonomous delivery robots may transport medicine throughout the city 24 hours a day. Emergency response systems could calculate the fastest route to any location within seconds. Education is expected to become equally advanced. Digital classrooms, interactive learning environments, virtual reality laboratories, and AI-powered teaching assistants could completely change the way students learn. Instead of traditional classrooms alone, education may become a personalized experience adapted to every student's individual progress. The same philosophy applies to workplaces. Many office buildings inside the line are expected to use intelligent automation systems that adjust lighting, temperature, ventilation, and energy consumption automatically. Employees may work inside highly connected environments, supported by advanced communication technology and artificial intelligence. But perhaps the most impressive feature is sustainability. Modern cities consume enormous amounts of energy. Cars release pollution. Buildings waste electricity. Roads require huge areas of land. The line attempts to solve many of these problems at once. Because there are no private cars on the surface, air pollution could be dramatically reduced. Pedestrian-friendly neighborhoods encourage walking instead of driving. Renewable energy from solar and wind farms is expected to supply much of the city's electricity. Advanced recycling systems aim to reduce waste. Water recycling technology helps conserve valuable resources. Even the city's vertical design helps protect surrounding nature by reducing urban sprawl. Instead of covering thousands of square kilometers with roads and suburbs, most development remains concentrated within a narrow corridor. This leaves much of the surrounding landscape untouched. However, building a city this ambitious is far from easy. Engineers must solve problems involving structural stability, expansion caused by extreme desert temperatures, transportation systems, energy production, water supply, communications, emergency response, and millions of future residents living inside a single connected structure. Every detail must work perfectly, because even the smallest engineering mistake could affect one of the most complex construction projects in history. And this is only the beginning. As construction moves deeper into the Saudi desert, one question becomes impossible to ignore. How do you build a city that stretches for 170 kilometers without compromising strength, safety, or efficiency? The answer begins beneath the sand. Before a single wall can rise above the ground, engineers must first create one of the largest foundation systems ever attempted. The desert may appear flat and stable, but underneath lies a complex combination of sand, gravel, rock, and uneven geological layers. Every section of the ground must be carefully analyzed using advanced geological surveys, satellite mapping, and thousands of soil samples. Heavy drilling machines bore deep into the earth to study the strength of the ground. Engineers use powerful computer simulations to predict how the soil will behave under the enormous weight of the structure. Only after years of planning can construction truly begin. Millions of cubic meters of earth are excavated using gigantic excavators, bulldozers, and autonomous construction vehicles. Entire sections of the desert are transformed into perfectly engineered construction zones. Some areas require blasting through solid rock, while others must be reinforced with massive concrete foundations capable of supporting one of the world's largest buildings. Unlike traditional cities that spread outward, the line concentrates everything into a narrow vertical corridor. This creates enormous pressure on the foundation. Every meter must safely carry the weight of residential buildings, offices, schools, hospitals, transportation systems, parks, utilities, and millions of future residents. To achieve this, engineers rely on high-strength reinforced concrete combined with massive steel reinforcement cages. Thousands of workers operate around the clock, while giant concrete pumps continuously pour specially designed concrete mixtures capable of surviving extreme desert temperatures. But the foundation is only the beginning. Above it rises one of the most extraordinary architectural designs ever imagined. Instead of ordinary buildings, the line consists of two gigantic mirrored walls extending across the desert almost as far as the eye can see. Each side rises hundreds of meters into the sky. The reflective glass exterior is designed to mirror the surrounding mountains, sand, and sky, making the structure appear almost invisible from a distance. During sunrise and sunset, the changing colors of the desert will be reflected across the enormous surface, creating an entirely different appearance throughout the day. However, building mirrored skyscrapers in one of the hottest environments on Earth creates major engineering challenges. Summer temperatures in parts of Saudi Arabia can exceed 50 degrees Celsius. Steel expands as temperatures rise. Glass also reacts to heat. Concrete expands and contracts over time. When a structure stretches for 170 kilometers, even tiny changes in temperature can create massive stresses. To solve this problem, engineers are designing advanced expansion systems that allow different sections of the building to move slightly without causing structural damage. Special flexible joints will absorb movement while maintaining the strength of the overall structure. The exterior glass is also expected to use advanced coatings that reduce solar heat while reflecting sunlight away from the building. This helps lower indoor temperatures and reduces the amount of energy needed for cooling. Energy itself presents another enormous challenge. A city designed for millions of people requires an incredible amount of electricity every second. Instead of depending mainly on fossil fuels, the line aims to operate using renewable energy. Huge solar farms spread across the desert will capture the region's abundant sunlight. Powerful wind turbines will generate additional electricity whenever desert winds are strong enough. Large-scale battery storage systems will store excess energy during the day and release it at night, helping maintain a stable power supply. Water is another challenge. The surrounding desert receives very little rainfall. To provide fresh water for millions of residents, engineers are developing advanced desalination plants that convert seawater from the Red Sea into clean drinking water. Highly efficient recycling systems will. Construction requires enormous quantities of steel, concrete, glass, electrical equipment, mechanical systems, and advanced technology. Millions of individual components must arrive at exactly the right time. Supply chains stretch across multiple continents. Raw materials travel by sea, rail, and heavy transport vehicles before reaching the construction site. Managing such a massive logistics operation is one of the biggest engineering challenges of the project. Thousands of workers from different countries work together every day,